The topic of today's webinar is troubleshooting with SIP ladder graphs. What I'm going to do is try and achieve these three objectives, help everyone on the call to understand the different parts of the ladder graph tool and what they're useful for. I'm going to go over some common call flows and then interpret some of the common errors that happen on the switch. So these are the call flows that I'm going to go through. To start at the beginning, we're talking about SIP ladder graphs and their capability to help you troubleshooting with problems. So first, the way you get to a SIP ladder graph is from the portal call history page. So here we see the reseller view of the system, and if you click on call history, you see the call history details in the page. Mousing over any one of the rows in the call detail record will show you a trace button. It's the little magnifying glass. If you click on that button, you'll end up getting a modal that opens up with what is known as the SIP ladder graph. And down at the bottom of that modal, you'll see a couple buttons. One is Download CVS, and the other one is View Full Trace. If you click View Full Trace, you now get a new window popping up, and it will show you a page that looks like this. Now, for troubleshooting purposes, this URL will get you to this SIP ladder graph from anywhere. You don't have to be logged into the portal. You can email it to somebody. If they clicked on that link in the email, they'd open up and they'd see this page too. When you're interacting with our support team, this URL is what we'd like you to send us. Primarily because, as you probably know, if you download the CSV file, which is the other way you can view the SIP details, you don't get the visual representation. It's harder to interact with the call flow. So it just takes a little bit more time from the support perspective to find out what's going on. Also, it's from the CSV record itself, it's not easy to get to the ladder graph from this URL. So please send us this. So components of the ladder graph. So the important components are across the top. You'll notice that every vertical line has a heading at the top, and that heading is usually an IP address and a port number. So in this particular call, we see 5 different vertical lines. Each of those 5 different vertical lines represents a different SIP endpoint. So starting on the left, we have 73.204.140.216. That's the entity that's making the call. The next vertical line says NetSapiens NMS. Then to the right of where it says NetSapiens NMS, you have 3 vertical lines. And you'll notice that of those, 2 of them have the same IP address. 96.254.192.77 is there twice. And then all the way on the right, you have another IP address, 97.76.90.211. Now, the reason the 2 vertical lines in the middle have the same IP address is because they represent 2 different SIP phones that are behind the same router. Of course, the different port numbers allow the system to communicate with each one separately. So the vertical line that says NetSapiens NMS at the top of the line is always going to be the PBX. So this is the switch that all of the other SIP devices or SIP endpoints are interacting with. And generally, you're going to read this ladder graph from the top going down. So the first event to happen will always be the topmost horizontal line. In this case, it's the invite on the left-hand side. So that invite is always going to be displayed in the right-hand panel. And in that right-hand panel, you're going to see the contents of that invite message. And I'll just briefly touch on some of the components of this. This is a SIP invite, and I'm not going to spend too much time explaining SIP. There are plenty of resources online that will help you to learn about SIP if you need to know it, but I'm just going to touch on some of the basics here. So in this SIP invite message, we see that the call was from Frank at extension 4607, and it was to extension 1002, which happens to be my extension. So you see both the extension number and the domain in the from and to message. You'll also notice that it shows you what the user agent is. And the user agent is always going to be the type of SIP device that is generating that message. So in this case, Frank was calling from a Polycom VVX400. Down here at the bottom of this SIP invite is what's known as the SDP, or Session Descriptor Protocol, or session, the session description. And that contains the codecs that are supported by this end device. So what's happening is this end device extension 4607 is sending an invite and saying, hey, these are all the codecs that I can support. And the priority that they're showing up in from top to bottom is the preference. So what this endpoint is saying is, I prefer to talk using PCMU, but I can also support G722, G722.1, and so on. Now, what controls the actual codec that's being used is the endpoint that answers the call can say, okay, of all those codecs that you support, I'm going to choose this one. Okay, and then the other important part when you're looking at a SIP message is it's always going to say where the packet was received from. So in this case, we see that the packet was received from 73.204.140.216, or Frank's router. Now, the other important component of the SIP ladder graph is the curved line that says switch logic. When you click on that curved line, you get something that looks like this. And this is very important, and this is something that's unique to NetSapiens. When you see SIP ladder graphs from other vendors, you won't see the switch logic generally. What this does is it tells you what's going on inside the switch between the SIP messages. It's very important because it gives you context to what's happening. You can see that between the first event, which was the invite, and the second event, which was the PBX saying, hey, give me your credentials, this is what's happening in the switch. So it's figuring out who that user is and what their priorities are. And I'm going to speak more about that in a little bit. And then also worth noting is every horizontal line in this ladder graph is clickable. And when you click on it, let's say you were to click on that trying line, you're going to see the contents of that message. So in this case, we see that this trying message is going from the PBX to Frank's device, and the contents of that message are here in the right-hand pane. And again, at the second line from the top of that message says the message is being sent to, and it has Frank's IP address there. Now, on the left-hand side of the ladder graph, you have line numbers. So often when you're interacting with support and you have a question, you submit a SIP trace URL, somebody in support will say, hey, take a look at line whatever. And that allows you to view a specific part of this graph. And then next to the line numbers, you have timestamps. So this is important because it gives you a reference as to what happened and when during the call. So we can see that this call at the very top line, line 1, has the invite going to the PBX at 7:39 p.m. and 18 seconds. And going down to the ringing message on line 17, we see that happened at 7:39 p.m. and 19 seconds. So it was 2 seconds, or 1 second rather, between the time when the phone sent the invite to the PBX and the time when the PBX sent back a ringing message, which was basically the ringtone that the caller hears. Okay, so that's the components of the SIP ladder graph. Now I'm going to get into some of the common call flows that you'll be seeing. So this is the same ladder graph I was looking at a second ago. What you'll see highlighted here now are the other side of this call. So what happened is the call came into the PBX, and then the PBX decided that this call had to ring 3 different phones. So it's SIM ringing my 3 extensions, which are 1002W, 1002D, and 1002. And you'll see that there's a separate SIP invite for each of those calls to each of those devices. So those are lines 9, 10, and 11 on this graph. And you'll see that the first invite is going from the PBX to the IP address represented by that first vertical line to the right of the PBX, 96.254.192.77, and so on for the other SIP invites. Now, you'll see that each of these devices, all those extensions, replied with ringing messages, which means that they were all ringing after they received the invite. And those ringing messages are represented by the horizontal lines coming back from each of those vertical lines. And then finally, we see that one device, in this case it was extension 1002W, sent an OK message. And the OK is signifying that the call was answered, and the OK packet is highlighted in the right panel. So you can see everything about the device that is answering the phone from that OK packet. Notably, you can see that the device type is a Cisco SPA504G, and if you look at the contact header of that device, it has the extension number, which is 1002W. Okay, so a word about switch logic. In that call flow, on line 8, you see that there's a switch logic arrow between the horizontal line that's from the PBX to the caller and the first call that goes from the PBX to the SIP devices. If you click on that line, you see what's in the left-hand panel. And I just copied it and pasted it into a text editor so it's more obvious what's happening here. But if you were to look closely at this first line in the switch logic, you would see this. And what you would see is that the switch says, okay, I've got a call coming from extension 4607. It's going to 1002. So it takes a look at the rules for user 1002, and it says, okay, the time frame for this call is time frame 0, which is basically the default time frame. And if I was using my default time frame at the time of this call, if it were a different time frame, there would be a different index number after that equal sign. In any case, it sees that the rule associated with that time frame is that is ring all devices. So it's going to find all of the devices that belong to user 1002, and this is them. So I've got about 8 or 10 different phones registered to my extension, and these are all the different extension numbers. So from that one piece of information, you get, or from that one packet, you get a lot of information. For one, it's telling you all of the different devices that belong to this user, so that when you check off that ring all devices in the answering rule, this is what the switch interprets as all of the user's devices. So if you have a situation where somebody has multiple devices and one of them isn't ringing, and you were to look at this particular line in the switch logic, and that device was missing, you'd know that the switch doesn't know about that device. Probably the device is not registered. Okay, so what happens when a device is not registered? Well, the next call flow is showing what happens when a device registration is expired. So here's a call that I made I unplugged all my devices and called my DID number. So here was a call to my number, and this is going to, you'll notice that there are only 2 vertical lines here. So the call came in, and in this case, the call was coming in from a DID, and it hits the PBX. There's nothing on the right side of the PBX vertical line because the PBX never tried to ring anything. And the reason it didn't try to ring anything is because when it went to look for that device, it couldn't find it. So if you highlight the switch logic for that part of the call, you see this line, and it's telling you what's going on inside the switch. It says, well, I'm trying to look up the registered user agent for extension 8899, and oh, the registration is expired. So what's happening is it looks up the registration, it sees the registration is expired, and then it goes on to the next rule, which happens to be send the call to voicemail. You can tell all of that by just reading your way down this switch logic and seeing what happens. And there's a lot of stuff here that is extraneous that you probably don't need to look at. You just need to look at the decisions that the switch is making. So and it's not shown here, but this is showing all the possible routes because it's looking for other ways to connect the call to extension 8899. And I don't have it in this panel, but if we looked closer, and actually we can look closer, Let me just pull that up. If we looked closer into switch logic, we would see that it decided finally to send it to voicemail. So that's pretty much how the switch logic can be used to figure out what's going on in the call. And you'll notice that this part of the switch logic, I clicked on this curved arrow, came right before the bye message. So that's right before, in this case, when I was calling into my own extension. When I called in and I heard the voicemail came on, I hung up. So that hang up is represented by this bye message coming from the DID going to the PBX. Okay. The next call flow is something that's pretty common. This is a common support issue. The support request is generally something like, hey, so-and-so's phone isn't ringing. Can you help me figure out why? In many cases, the reason why is because the phone is on Do Not Disturb. Now, in many cases, depending on the phone, for Polycom and Yealink phones, when you press the Do Not Disturb button on the phone, it turns on Do Not Disturb on the switch. So that means the call will get to the PBX, and the PBX is not going to try and ring that device because that user has Do Not Disturb enabled. If you're using a phone, though, that does not synchronize with the switch, and in this case, I was calling a Cisco phone, which does not synchronize, when you ring that phone and the phone has Do Not Disturb on, the phone's going to say, hey, I can't take this call. And so this is what's happening. In this particular call, I called my DID, and you'll see that the invite is going on line 5 from the PBX to my IP address at extension 1002W. Now, my phone, 1002W, responds with busy here. And you can see here the phone type is a Cisco SPA 504G. Again, if it were a Polycom, the PBX would never have tried to ring the phone because it would have known that the Do Not Disturb was enabled. But in this case, the phone replied with busy here. And then, of course, the PBX replied back to the caller with the voicemail greeting, because the next rule, if you had looked in the switch logic, would be play voicemail. So here's the switch logic, and if you were to highlight that switch logic, you'll see not only is that 486 response, the busy here message, shown in the graph, it's also shown in the switch logic. Now in this case, it's not as obvious what it is. It says process 4086 response from the IP address. So unless you know what you're looking for and you know that 486 is a SIP error code, you might miss that. But sometimes when you have complicated call flows where there's dozens of devices being rung at the same time, the switch does not always get those SIP, I'm getting horizontal and vertical mixed up, those horizontal lines correct. So sometimes those horizontal lines are missing just because of, in a very complicated call flow, it's hard to represent that. But you can always find in the call logic what's going on. So in this case, if you know that a 486 represents something saying, hey, I'm busy, you would see that this is what's going on in this particular call. Again, it's much easier to see it this way, right, with the busy arrow going from the IP address to the PBX, but that's not always going to be there, so you can always fall back on the switch logic to see what's going on. Again, this takes a little bit of knowledge about SIP. You have to know that what a 486 message is, but if you're going to be successful in reading these graphs, it helps to learn a little bit about SIP. Okay, the next call flow I'm going to go over is a call being forwarded. Now, in this case, we start out with a call to my extension, and again, the call is ringing extension 1002W. So we see the invite going from the PBX to extension 1002W. This time, I took Do Not Disturb off and I put call forwarding on. And we see now that extension 1002W responds with this SIP 302 message. And over here on the right-hand side, if we were to look at that 302 message a little more closely, we would see this. And 302 corresponds to the text moved temporarily. So that usually when you turn on forwarding on the phone is going to reply with this move temporarily message. And the important part of this message is the contact header, because this is telling you where the call wants to be moved to. So this is saying, this is the Cisco phone saying, this user is temporarily somewhere else, and here's where you should try him. And in this case, it's this phone number. So this is telling us that the phone wants the call to be forwarded to 858-764-5200. So if we look back at the switch, at the SIP ladder graph, we see now after receiving that 302 message from the phone, down on line 12, the switch is now trying to make a call to the new destination. And we have that horizontal line going from the PBX to the IP address 70.42.44.85. And this is actually a call to the PSTN where the switch is trying to connect that forwarded call. Now again, it's important to note that this is a call being forwarded from the phone itself, from the device itself. Again, if this were a Polycom phone, we try and synchronize do not disturb and call forward. So if you had turned on call forward on a Polycom phone, it would have turned that call forwarding rule on in the PBX, and the PBX would know to forward the call without ever trying to ring the device. But in this case, since the Cisco phone does not support that synchronization, it's the Cisco phone itself forwarding the call, and now the switch trying to connect that forwarded call. So this is another very common support issue that we encounter where the support request is, hey, so-and-so's phone is not ringing. Instead it's going to somebody else's voicemail. And if you look at the SIP message, you say, oh, it's because that person has enabled forwarding on their phone and the call is being forwarded. Well, this is how you can determine that by looking at the SIP messages. So just going down on this ladder graph to line 20, we see that the invite was made to the PSTN, and the PSTN on line 19 is given session progress, which is session progress is the same as ringing. And on line 20 was the OK message, meaning that the person at that number answered. So in this particular flow, I'd like to point out a couple things. First, if you look at the two vertical lines on the either end of this flow, on the left-hand side, you see 75.98.50.51. This is our ingress proxy. So any calls from a DID coming to the PBX will come from this IP address. On the right-hand side, 78.42.44.85 is our egress proxy. So all the calls going from the PBX to the PSTN will go to this IP address. And actually, these IP addresses, there's two of each of these, one in New York and one in Dallas. And in this particular case, I'm not sure why, but even though the call came in through Dallas, when the PBX made the call out, it sent the call out through the New York egress proxy. In any case, you should get to know the IP addresses of the ingress and egress proxies, because you'll end up seeing them for every call that comes in from a DID or gets forwarded or called out to the PSTN, because you'll always see those ingress and egress IP addresses. And just in general, when you're looking at a SIP ladder graph, it's very helpful to know what the different SIP endpoints are. So if you see an IP address that you're not familiar with, either that IP address is a registered SIP phone from a customer, and you can assume that IP address belongs to the customer, or it's an IP address that belongs to SkySwitch, and it's one of our network components. And just in case you're interested and have not seen it before, in our help documents there is a diagram that shows all of the different components in our network representing the IP addresses that you would see. So it shows you our ingress proxies and our egress proxies and the IP addresses of all of our switches. Okay, moving along, the next diagram is going to be call transfer. So this is a little bit of a longer graph, so I had to break it up into a couple parts. But we start off the same way. Call to my DID number, 747-777-8710. Rings my extension. In this case, it's extension 1002B. So here we see on line 5, we see the invite from the PBX to extension 1002B. Now, in this case, the call was answered. So on line 11 of this graph, we see the 200 OK message going from extension 1002B back to the PBX. Now, if you look on the right-hand panel, the actual contents of that 200 OK message, we see that this is a Grandstream phone. You see about midway through that 200 OK message, it says user agent Grandstream GXP 2130. I used the Grandstream for this call just because Grandstream does call transferring a little bit different than other phones, and so I thought it would be instructive to show that to you. So the call is answered, and then down here on line 28, we see what's in the SIP request line, which is always the top line of the SIP message, is a refer message. So a refer is one of the ways that a SIP endpoint can transfer a call. There are other ways with re-invites where instead of sending a refer message, the SIP phone would just say, hey, I'm just going to send you another invite, and I want you to send this call somewhere else. The difference between a 302, which is a call forward, and a refer is that for a 302 message, the call is never answered, right? So the phone rings. It knows that it wants to forward a call somewhere. It sends back a 302. It says, hey, this call has moved. Try somewhere else. In this case, the call was answered, and when you hit the transfer button, this phone is going to refer the call somewhere else. Now, the contents of the refer message are worth taking a look at. So again, the request line of this SIP packet is always the line that talks about the timestamp and where the packet came from. So it says the call is a refer message. You can tell that from that line. And the important other line in this is the refer to. So this is where the call wants to be transferred to. So in this case, I answered the phone and I tried to transfer the call to extension 4905. So after receiving the refer message from my Grandstream phone, you'll see the very next line, horizontal line, line 30, is the PBX saying, I accept that refer. So it's sending a 202 accept message back to the phone. And then the very next line is the switch saying goodbye to the phone. So line 31, after it accepts the refer, it says, okay, now I'm hanging up the call. So now, for all intents and purposes, the call between the PBX and extension 1002B is finished. But the PBX knows that the call is being transferred, so what it's doing next is it's sending a new invite to the transfer destination, which in this case is extension 4905. Oops, I didn't want to do that. Bear with me. So on the right-hand side of the PBX, right, where the call is talking to extension 1002 and then the call is made to 4905, I think that's pretty clear. But what's happening on the left-hand side of the call is worth paying attention to. So let me back up here. So here, the buy message is coming from, on line 31, is coming from the PBX and going to extension 1002B. The call is now over between the PBX and 1002B. But the call is still going on between the caller and the PBX. So what you see next on line 32 is, remember, there is an existing session going on between the caller and the PBX. But this invite going from the PBX back to the caller is basically telling the caller, hey, I'm going to do something else with this call. And actually, I can pull up that flow because I think it's worth looking at. This invite here, which is, again, from the PBX. Am I looking at the right place? Oh, I'm sorry. Here I am. Okay, so here's the refer. Here's the accept. Here's the buy. Now there's a new invite going back to the caller. And what's happening here is the PBX is putting the caller on hold. So really all it's doing is it's changing the port number that the audio is coming from to a new port where it can play an audio message. In this case, it probably was saying, it was actually putting the call on hold, so it was playing my on hold message. And while this caller is on hold, it now is making a new invite to extension 4905. Okay. All right, so the next call flow is outbound call being rejected. So in this particular call flow, we have, again, you'll notice there are 3 vertical lines. The vertical line on the left represents the caller. The vertical line in the middle is the PBX. The vertical line on the right is one of our egress proxies. So it's the outbound proxy facing the PSTN. So in this invite came from extension 1015, and you can see it was a call going to 956-237-3793. So if we were to look at the switch logic for that call, we would see the switch interpreting who that caller is and whether they're allowed to make the call. It determines that they are, and so it now tries to make that call to the PSTN. So it sends this invite to our termination partner to make the call. What happens, though, is that the terminating carrier responds with this 603 declined message. So this is basically the carrier saying we can't take this call for whatever reason. And you'll see in the right hand pane that is the content of the declined message. So the PBX gets the declined message from the outbound carrier, and it sends that declined message back to the caller. So and what generally happens when a caller gets a 603 decline is you hear a fast busy message on the phone. So this caller made the call, heard a fast busy. Now, so this is another instance where it's helpful to know a little bit about SIP, because a SIP 603 message is this particular kind of message where the switch will not try to go to find another route. 603 is like a dead end where it says, okay, we just can't make this call, and it sends that 603 message back to the caller. The caller hears fast busy. There are numerous kinds of error messages that you can get back from a carrier, and depending on what that message is will dictate how the PBX responds to it. Sometimes it will try another route, and the SkySwitch has multiple carriers. We can terminate calls to dozens of different endpoints. But in a call like this, where we get a 603 message, the purpose of the 603 is, hey, this is a bad number. Don't try and call again. And the PBX respects that. So if you are looking at this, generally what will happen is we'll get a support ticket that says so-and-so tried to make a call and they got a fast busy. Of course, for your own benefit and you providing support for your customers, it's helpful if you know a little bit about SIP and you realize that what's happening is the carrier thinks this is a bad message. What you could do is you could contact support and say, hey, this carrier is sending us a 603. Could you change routes, right? And generally speaking, if we were to get that kind of support request, our time to resolution on